So to find the molecular geometry for C2H6, we'll start with the Lewis structure. We'll focus on the carbon on the left since it's symmetrical with the carbon on the right. So once we find the one on the left, it'll be the same molecular geometry for the carbon on the right. We can see there are four things attached to the carbon. We have the three hydrogens, and then we have the carbon, the other carbon. So with those four things, you can imagine that they're going to spread out as far away from each other as they can, while still remaining bonded to the carbon. And that'll give us the molecular geometry for C2H6. And it's going to look something like this. So with respect to this carbon right here, we have what's called a tetrahedral molecular geometry. It's also the same for this carbon right here. So they both have tetrahedral molecular geometries. We could also find this out using the AXN notation. A, that's the carbon we're interested in. X, that's the number of things bonded to the carbon, and we have four things, the three hydrogens, and then that other carbon there. And then N, that's the number of non-bonding electron pairs. Well, all of the electron pairs here with the carbon are involved in chemical bonds, so we don't have N. We can get rid of that. You could have memorized that AX4 is a tetrahedral molecular geometry, or if you have it, you can look it up on a table. So as we go down our table, we start out with AX2, which is linear, and then right below it, we have AX3, which is trigonal planar, and then we get to AX4, which has a tetrahedral molecular geometry with bond angles of 109.5. The bond angle here, this one here, that would be 109.5. Same with this one. And then over here, we have 109.5, and then on the other side. So those are the bond angles for C2H6. It has a tetrahedral molecular geometry. This is Dr. B, and thanks for watching.